kinematics, one dimension. From top of a tower of height h, we have calculated velocity on reaching the ground, maximum height above the top of the tower, and equation for height of the tower. Now we will continue with the same. One example, we will take two stones. Example, two stones projected, two stones, one projected vertically up from the bottom of the tower H, and other dropped down at same instant. Find the time at which they meet each other. So let us go for the solution. Simple it is. Tower of height h. Let us take the tower of height h. One is projected vertically up, other one is dropped down. Dropped down, let me name it as stone 2. Projected up, let me name it as stone 1. Projected up body with velocity u. And dropped, we know when a body is dropped, its initial velocity is 0. Distance covered by the dropped body, as already we know, freely falling body distance is equal to half gt square. In the same time, distance covered by vertically projected up body, let us take it as S1. S1 equals ut minus half gt square. But total height is h. So when we add these two, h should be equal to S1 plus S2. So h is equal to ut minus half gt square plus half gt square. Minus half gt square plus half gt square get cancels. So h is equal to ut. So very simple case. Time taken to meet each other is h by u. This is the time after which two stones meet each other. So two stones, one is projected vertically up, one is dropped down, one is from the foot of the tower, one is from top of the tower. He is asking us where they will meet. So distance covered by first stone, distance covered by second stone in the same time. They should meet in between the height of the tower, means this is a condition. Total distance h. S1 distance covered by the first stone which is projected vertically up, distance covered by the second stone which is dropped. So h is equal to ut minus half gt square plus half gt square. On simplification, we are getting t is equal to h by u. This is the time after which two stones meet each other. We will go for one more example. Suppose if he is asking us to find the distance covered by a vertically projected up body, in the last second of total journey. So body is projected vertically up. ఒక స్టోన్ పైకి విసిరినప్పుడు వాట్ ఈస్ ద టోటల్ జర్నీ ఇన్ ద లాస్ట్ సెకండ్. లాస్ట్ సెకండ్ అంటే అది పైకి వెళ్ళి కిందికి వచ్చేప్పుడు లాస్ట్ సెకండ్ తీసుకోవాలి. దట్ ఈస్ వాట్ ద మీనింగ్ ఆఫ్ డిస్టెన్స్ కవర్డ్ ఇన్ ద లాస్ట్ సెకండ్ ఆఫ్ ఇట్స్ జర్నీ. ఇక్కడ అడుగుతున్నాడు, ఇది లాస్ట్ సెకండ్, గోయింగ్ అప్ యాజ్ వెల్ యాజ్ coming down. That is a total journey. Distance covered in the last second is equal to distance covered in first second of upward motion. That is, since it is a vertically projected up body, we will take it is projected up with velocity u, then s is equal to u in 1 second minus half g t square. So therefore s in the last second covered is u minus g by 2. Distance covered in the last second is equal to distance covered in the first second of a vertically projected up body. So this is the distance covered in the last second of motion of a vertically projected up body. Suppose if he is asking what is the distance covered in the last second of upward motion, last second of upward motion, then it is very simple. You calculate distance covered in the first second of downward motion. Distance covered in the last second of upward motion is equal to distance covered in the first second of downward motion, because it explains us when a body is projected vertically up, the motion is symmetric. That is a simple logic. If you there in your mind, distance covered in the last second of upward motion is equal to distance covered in the first second of downward motion. Similarly, distance covered in the first second of upward motion is equal to distance covered in the last second of complete motion, that is total motion. Whatever we have seen, that we are getting d is equal to u minus g by 2. So in this way, if the subject is there, that is logic is there in your mind, physics is simple. Physics is not based on formulas, it is based only on logic and the concept in your mind. మీరు లాజిక్ డెవలప్ చేయండి, ఫిజిక్స్ మైండ్ ఆటోమేటిక్గా ఇంప్రూవ్ అవుతుంది. Now we'll go for second part of kinematics, that is two-dimensional motion. Kinematics, two-dimensional motion. Mostly we'll be dealing with projectiles. Projectiles. So it is in two-dimension motion. We are having oblique projectiles, horizontal projectile. So first we will deal with oblique projectile. When a body is projected at an angle theta with horizontal, then it traces a parabolic path. You start projected from O, it reaches the same level of projection at A, reaching the same level of projection at A. This is said to be projectile, where theta is not equal to 90 degrees nor 0 degrees. Now it has two-dimensional motion. One is along x-axis, one is along y-axis. So along x-axis, if you take the component of velocity u cos theta, already we have learnt in vectors how to write the components of a given vector. U cos theta is on horizontal direction, u sin theta is in vertical direction. U cos theta is along x-axis, u sin theta is along y-axis. This is initial velocity along x-axis, initial velocity along y-axis. So if you write the total velocity vector u cos theta I cap plus u sin theta j cap, this is initial velocity vector. If you want final velocity vectors, always the horizontal velocity is constant, because along horizontal direction there is no acceleration. So horizontal motion is unaccelerated motion. Vertical motion is only accelerated motion. This is the reason horizontal velocity does not change. That means it is not variable. అది మారదు, ఎప్పుడు కాన్స్టెంట్గానే ఉంటుంది హారిజాంటల్ వెలాసిటీ. రీజన్ ఏంటి? యాక్సిలరేషన్ హారిజాంటల్ డైరెక్షన్లో యాక్ట్ అవ్వదు. ఎందుకంటే g ఆల్వేస్ యాక్ట్స్ వర్టికలీ డౌన్వర్డ్స్, హారిజాంటల్గా యాక్ట్ అవ్వదు. అది హారిజాంటల్ కాంపోనెంట్ ఆఫ్ యాక్సిలరేషన్ డ్యూ టు గ్రావిటీ ఈజ్ 0. అందుకని హారిజాంటల్ వెలాసిటీ ఎప్పుడు కూడా ప్రొజెక్టైల్ మోషన్లో కాన్స్టెంట్ ఉంటుంది, ఎస్పెషలీ ఆబ్లిక్ ప్రొజెక్టైల్. వర్టికల్ మోషన్ vy ఇది మారుతూ ఉంటుంది. వర్టికల్ మోషన్ ఈజ్ వేరియబుల్. ఇన్ వర్టికల్ మోషన్ vertical velocity is variable. If you take vertical velocity after t seconds, u cos theta minus gt. This is the vertical velocity after t seconds. So complete velocity of a projectile, we can write it as v bar equals u cos theta I cap minus u sin theta minus gt j cap. So this is the complete velocity vector, final velocity vector. If you go for distance, horizontal distance, let us take the horizontal distance covered is x. Horizontal distance is equal to horizontal velocity into time. Vertical displacement y is equal to, will apply s is equal to ut minus half gt square. Ut u sin theta t minus half gt square. So this is vertical displacement. When we substitute the x value in this equation, we will get y equals x tan theta minus gx square by 2u square cos square theta. I am substituting the t value from first equation in second equation. What is t value from first equation? X by u cos theta. So if I substitute here x by u cos theta, yes, x is as it is, u get cancelled, sin theta by cos theta is tan theta minus as it is g by 2 as it is. In the place of t, what we are substituting? X by u cos theta. So it will become x square by u square cos square theta. This is said to be equation of parabola, or we can write this as y is equal to ax minus bx square, equation of parabola, equation of parabola. So then we can say path of a projectile is parabola, where a equals what? Let us take it as tan theta. B equals, what is this B equals? G by 2u square cos square theta. So this is what y is equal to ax minus bx square. When we calculate range of a oblique projectile, range means horizontal velocity into time of flight. Horizontal velocity into time of flight is range. So capital R equals u cos theta into time of flight is t. So if I continue that, R equals u cos theta into time of flight is 2u sin theta by g. Ultimately, range equals u square 2 sin theta cos theta is sin 2 theta by g. This is a range of a projectile. Range means the distance covered from O to A in horizontal direction. Whatever the distance it will cover from O to A in horizontal direction is range. So range is equal to u square sin 2 theta by g. If he is asking for maximum range means u square by g, that is sin 2 theta should be equal to 1. That is theta should be equal to pi by 2. Therefore, theta will become pi by 4. So, when angle of projection is pi by 4, then range is maximum. If you go for time of flight, if you want to calculate time of flight, total time taken by a projectile to move from O to A is time of flight. In time of flight, it has vertical displacement, it will become 0. It has only horizontal displacement. So, in time of flight, vertical displacement is 0. So, when we apply S is equal to uy t minus half gt square, vertical displacement should be 0 in time of flight. So, when we take vertical displacement is 0 in time of flight, 0 is equal to uy t minus half gt square. On simplification, t is equal to 2uy by g, that is 2. What is uy? Initial vertical velocity u sin theta. I will substitute here u sin theta by g. So, this is time of flight 2u sin theta by g. If you want to calculate H max, maximum height, final v square minus u square is equal to minus 2g h max. So, final vertical velocity at h max is 0. Initial vertical velocity is u sin theta. So, u square y is equal to minus 2g h max. So, h max is equal to u square y by 2g. What is uy? Uy is already u sin theta. So, when I substitute there, h max is equal to u square sin square theta by 2g. So, this is what h max, time of flight, range. So, next we will try relation between h max and time of flight. Relation between maximum height and range, h max divided by range. What is h max? We got u square sin square theta by 2g. What is the range? We got u square sin 2 theta by g. So, h by r is equal to u square sin square theta by 2g into g by u square 2 sin theta cos theta. I am writing sin 2 theta as 2 sin theta cos theta for trigonometry. So, u square get cancels, g get cancels, one sin is out, remaining is h by r equals sin theta by 2 2s are 4, 1 cos theta is here. So, h by r equals tan theta by 4, that means 4h is equal to r tan theta. Relation between maximum height and range. Similarly, we can calculate the relation between, this is the relation between h and r. Now, we will calculate the relation between maximum height and time of flight. What is time of flight? We know time of flight is equal to 2u sin theta by g, and maximum height is u square sin square theta by 2g. Now, when we work out, so we will take h by t square. H is u square sin square theta by 2g by t square. T square what will get? T square u square sin square theta by g square. So, h by t square is equal to u square sin square theta by 2g into g square by 4u square sin square theta. So, u square sin square theta, u square sin square theta, g 1g get cancels. So, ultimately h by t square is equal to 2 4s are 8, 1 by 8 into g. So, what will get ultimately? Capital H is equal to 1 by 8 g t square, capital H is equal to 1 by 8 g t square, or you can write it as 4h is equal to 1 by g t square. I am writing 8 as 4 into 2, 4 I am bringing this. So, 4h is equal to half gt square. If I take this as equation 1 and this as equation 2, from 1 and 2, from 1 and 2 we will get 4h is equal to r tan theta, which is equal to half gt square. Relation between maximum height, range and time of flight. This is a very important equation to solve any relation between height, range and time of flight. When you want to calculate velocity of a projectile, what is vertical velocity? Vertical velocity, either you can write u sin theta minus gt after t seconds. Horizontal velocity is always constant. So, total velocity of a projectile is horizontal velocity square and vertical velocity square from the concept of vectors. So, ultimately velocity of a projectile is u square cos square theta plus u square u sin theta minus gt whole square. This is the velocity of a projectile. If you want to calculate angle made by the projectile after t seconds, suppose if the projectile is given, so tan alpha is equal to Vy by Vx, which is equal to u sin theta minus gt by u cos theta. This is angle made by the projectile after t seconds. So, this is how we can calculate velocity, maximum height, range and time of flight, relation between maximum height, range and time of flight. Body projected at an angle theta naught with horizontal. It traces the vertices of an triangle ABC with base angles theta 1 and theta 2. Find the relation between theta naught, theta 1 and theta 2. So, a body is projected at an angle, body projected at an angle theta naught with horizontal. It traces the vertices of a triangle ABC with base angles theta 1 and theta 2. Find the relation between theta naught, theta 1 and theta 2. It is also good application of projectiles. So, first we will draw a triangle ABC, it is projected with an angle theta naught. Now, it will trace the vertices of a triangle ABC. ABC is a vertices of triangle. Body is projected at an angle theta naught with the horizontal. He has given base angles as theta 1 and theta 2. He is asking us to calculate the relation between theta naught, theta 1 and theta 2. So, let us take this point as x comma y, horizontal distance is x, vertical distance is y. So, if this is D, so from triangle ABD we are getting tan theta 1 is equal to y by x, and from triangle BDC, this distance I can write r minus x, range minus x, BDC. So, here tan theta 2 is equal to y by r minus x. This is from BDC, this is from ABD. Let me take this as equation 1, equation 2. Now, adding 1 and 2, when we add 1 and 2, what will get? Tan theta 1 plus tan theta 2 is equal to y by x plus y by r minus x. So, if I take y common, this is 1 by x plus 1 by r minus x. So, y into will get r minus x plus x by x into r minus x. So minus x plus x cancels, so it is yr by x into r minus x. This is only purely mathematics. Now we will apply projectile, concept of projectile motion. From projectile motion, we know y equals x tan theta minus gx square by 2 u square cos square theta. So we can write y equals x tan theta minus g by 2 u square cos square theta. I will multiply with sin theta, tan theta for the numerator and tan theta for the denominator. I can do tan theta by tan theta, multiplying and dividing by tan theta for equation of projectile. This is what equation of projectile from our projectile motion just now we discussed. For this equation, I am multiplying tan theta and dividing tan theta. Instead of writing tan theta, what I am writing here? Sin theta by cos theta. So cos theta get cancels. When we simplify everything, we will get the relation as x tan theta minus x square tan theta by r, where r is what? U square sin 2 theta by g. So when we simplify this one, you will be getting this equation. When we write x tan theta common from here, you will be getting 1 minus x by r. This I will take, this is equation 3 and this is equation 4. So from 3 and 4, from equation 3 and 4, we can write tan theta is equal to tan theta 1 plus tan theta 2. So this is a relation we are going to get from equation 3 and 4, because what we will be getting here? Y by x is equal to tan theta into what you will get? R minus x by r, r minus x by r. So I will bring r this side, so it will become ry by x. So that is what from equation 3 and 4 you will get tan theta is equal to tan theta 1 plus tan theta 2. So we will go for another example. Find the velocity of a projectile at half of the maximum height. Find the velocity of a projectile at half of the maximum height. So we all know that horizontal velocity is constant, which is u cos theta, where theta is the angle of projection. Now for vertical velocity at half of the maximum height, v square minus u square equals minus 2g h maximum by 2. But what is h maximum? H maximum is equal to u square sin square theta by 2g. I will substitute that. So vy square minus uy is what we know, uy is u sin theta, therefore it is u square sin square theta minus 2g by 2 h by 2. H is how much we are having? U square sin square theta by 2g. So G 2 and 2 get cancels. So Vy is equal to u square sine square theta minus u square sine square theta. This is by 2. On simplifying, we will get Vy is equal to u sine theta by root 2. This is vertical velocity. Vertical velocity. Vertical velocity. This is horizontal velocity. Now, as velocity of a projectile is asking, to calculate velocity of a projectile, we will write V is equal to root of Vx square plus Vy square. Velocity of a projectile. Velocity of projectile. So, V equals root of, what is horizontal velocity? Horizontal velocity is u cos theta. So, u square cos square theta plus vertical velocity, what we got at half of the maximum height? U sin theta. So, it will become Vy square. So, u square sin square theta by 2. We will simplify it now. V is equal to root of 2 u square cos square theta plus u square sin square theta by 2. I will take u square common. So, it will be u root of, instead of writing 2u cos square theta, I will write cos square theta plus cos square theta plus sin square theta by 2. Cos square theta plus sin square theta is, cos square theta plus sin square theta is 1. So, we will write V is equal to u root of 1 plus cos square theta by 2. This is what we are getting velocity of a projectile at half of the maximum height. Instead of writing 2u cos square theta, I am writing cos square theta plus cos square theta sin square theta as it is. U square I have taken out. Cos square theta plus sin square theta is 1. So, 1 plus cos square theta, everything under root. So, V is equal to u into root of 1 plus cos square theta by 2 is the velocity of a projectile at half of its maximum height. When we go for horizontal projectile, horizontal projectile, horizontal projectile. Horizontal projectile means it is projected horizontally from a height. That kind of projection we are calling it as horizontal projectile. It is projected from a height h with a velocity u, then it traces a horizontal path. This is what horizontal projectile. X is said to be range. At any point it has two velocities, horizontal velocity and vertical velocity. Horizontal velocity is u, which is always constant, and vertical velocity is variable. Initial vertical velocity, if you take initial vertical velocity 0, final vertical velocity gt, this is after t seconds, or you can write Vy is equal to root of 2gy after covering height y. So, velocity of a projectile at any point you can write it as V is equal to root of Vx square plus Vy square. Velocity of a projectile. Velocity of projectile. If you want to calculate angle made by the projectile after t seconds. If you want to take the angle made by the projectile, suppose if this is the actual direction of projectile v, it makes an angle alpha with horizontal. Now he is asking us to calculate what is the angle made by the projectile after t seconds. So we require alpha. So from here we can write tan alpha equals Vy by Vx, which is equal to Vy is what? Gt, Vx is what? U. So tan alpha is equal to Gt by U, or you can write it as root of 2 Ghy by U. Either of the way you can calculate angle of the projectile after t seconds. If you want to calculate range is what? Horizontal range is equal to horizontal velocity into time of flight. Time of flight or descent, or time taken by a projectile to come down. T is equal to root of 2h by g. Time taken by the projectile to come down is root of th by g. So x is equal to u into root of 2h by g is range. This you can call it as time of descent also. Time of descent. So in this way the range, time of descent, velocity, and if you want displacement of the projectile, horizontal displacement, x is equal to simply ut. Vertical displacement, y equals half gt square. If I take this as equation 1, this as equation 2, from 1 and 2 we can write y is equal to half g. What is t value from 1? X by u. So this is x square by u square. So y is equal to g x square by 2 u square, equation of parabola. This is again equation of parabola. So here horizontal projectile is also tracing a parabolic path. Here we have seen that it is getting equation of parabola. So what is the difference between oblique projectile and horizontal projectile? Oblique projectile we are projecting at an angle theta with horizontal, whereas horizontal projectile we are projecting horizontally from a height h. So there is no angle made with horizontal, it is projected from a height h horizontally. Here also it has two-dimensional motion. In oblique projectile also it has two-dimensional motion. So what is the variation? Means the little variation where we find in the equations of range, equation of parabola, and calculating the velocities. So here I will take an example. A body is projected horizontally with velocity u from a height h. If range is equal to height, if range is equal to height, find u. So, a body is projected horizontally from a height h. If range is equal to height, he is asking us to find u value. So, now we will start solution. What is the range equation? Range equation is x is equal to u into root of 2h by g, and it is telling height h is equal to range. So, h is equal to r, we have taken r is equal to x. According to the question, height is equal to range, but range I am taking it as x. So, in the place of x I can substitute h. So, h is equal to u into root of 2h by g, squaring both sides, h square is equal to u square 2h by g. So, 1h cancels, remaining is what? U square is equal to gh by 2, or we will get u equals root of gh by 2. So, this is what we found. Is asking us to find u equal to height, find u is asking. So, we are equating height and range, h is equal to x. So, in the place of x I am representing it as h, squaring both sides, h square is equal to u square root of 2h by g, simplification you got u is equal to root of 2gh by 2. In the same way we can plot the graph also. If you plot the graph, he said it is projected horizontally from a height h. Now, this is a path traced by the projectile, and this is range. Now, when we join these two straight line from point of projection to landing, he said h is equal to x, h is equal to range. That means if it makes 45 degrees, then same equation you will get tan 45 is equal to 1, or h by r is equal to 1, h is equal to r. The question can be traced or given by giving height is equal to range, or if the line of sight joining from A to B makes 45 degrees, what is the u value? You may ask in different manner, either directly in this way, height is equal to range, or you may ask like line of sight joining A and B makes an angle 45 degrees. What is the velocity of projection? If it makes 45 degrees, tan 45 is equal to 1. Therefore, h by r is tan 45, which is equal to 1, h is equal to r. Either you may ask in this way or in this way, result is same. So, when we see another example, a projectile, a body projected at an angle 30 degrees, angle 30 degrees with horizontal. Find the horizontal, body projected at an angle 30 degrees with horizontal with velocity 10 meters per second. Take g is equal to 10 meter per second square. find first bit maximum height, second bit range. So solution, it is projected at an angle 30 degrees with horizontal with velocity 10 meter per second. By taking g as 10 meter per second square, he is asking us to calculate maximum height and range. Now this is what projectile? Horizontal projectile. First bit maximum height, h max is equal to u square sin square theta by 2g. U square, u is given 10, so it is 10 square. Sin 30 degrees square by 2, g value 10. Now when we simplify this, what will be getting? 110 get cancels, sin 30 is 1 by 2, so it is 10 into 1 by 4 by 2. So this is 10 by 8 meters. Now when we go for range, what is the equation for range? Range is equal to u square sin 2 theta by g. 10 square by 10 into sin 60 degrees. 110 get cancels. Sin 60 is what? Root 3 by 2. What is the final answer you will get? 10 into root 3 by 2, that is 5 root 3 meters. So this is maximum height and range. By observing the question, you should understand whether it is a horizontal projectile or oblique projectile. He has given with horizontal, angle made with horizontal. So immediately our idea goes for oblique projectile. Here we have seen it is projected horizontally from a height h. So this is horizontal projectile. So this is what the difference we should observe. It is based on your presence of mind how you will apply. So do as many problems as you can do, try them, then definitely you will be getting a good response, good confidence in physics. So we are seeing h max is u square sin square theta by 2g, 2g 10, sin 30 is angle of projection, sin square 30, sin 30 is 1 by 2, so this is 1 by 4. Out of 10 square, 10, 10 get cancels, so it is 10 into 1 by 4 by 2. So what you will get here? 10 by 4 by 4 is 10 by 8 meters, and here we are getting u square sin 2 theta by g, theta is 30, so sin 60, u square by g, 10 square by 10, 10 sin 60, 10 root 3 by 2, so 5 root 3 meters. In this way, we can do number of numericals in projectiles.